Hello and welcome to my presentation for my Interactive Advanced Concept 2, Lava Lamp Edition. So the goals and purpose of me doing this little experiment was to create this lava lamp-like effect just using materials that I had in my own house. This includes the bubbling like flowing effects that are in the closed environment of a lava lamp. So I'll show you the next couple photos, kind of how I did it. So here I have my vegetable oil, my Alka-Seltzer, my clear bottle, and then not pictured is my purple food dye that I used as well. So a quarter away filled the bottle with water, and then about 2/3 more of the way, a little bit more than that maybe, I filled it up with vegetable oil. And then I added in my purple food dye, and I noticed immediately that it dyed the water and not the oil, which I thought was interesting. And then I have my Alka-Seltzer tablets, and when I dropped those in, I immediately noticed a lot of really intense fizzing and bubbling, and the colored bubbles would form and rise to the surface. And I also got this really intense fizzing effect, less like a lava lamp and more of like a fizzing effect, like from like a soda fountain or something like that. But as you can see on the photo on the right, I tried to get a little bit better a picture. I did have some more defined bubbles later on in the reaction, and I took a photo of that here. You can kind of see some of the ones there. And then here is a photo of the fizzing that was kind of happening at the top. And then it kind of was almost making the whole bottle purple at one point, rather than just the water, rather than the oil not being dyed. So some observations that I made was initially the oil and water didn't mix when I poured them in my bottle. And when I added the food coloring, it only colored the water and not the vegetable oil. Like I mentioned before, as I showed you in those pictures. And then when I dropped my 2 Alka-Seltzer tablets in, it immediately started to bubble and fizz. I got a less dramatic bubbling effect when compared to real lava lamps and the video instructions. I noticed theirs were like really large, defined bubbles. Mine were a lot smaller, and I could only see them more towards the end of the reaction. So in a way, the fizzing effect mixed the colored water and oil, creating a whole purple bottle with the purple bubbles. And it lasted about 2 minutes for me. I know in the video they said like 5 to 10 minutes. Mine definitely was not that long, only about 2 minutes. And then once the fizzing slowed down, I was able to more clearly see the larger bubbles that were forming. So why did this happen? The water is more dense than the vegetable oil, so that's why it sinks to the bottom and the oil is on the top. I did some research, and the density of water is 1 gram per milliliter, and the density of vegetable oil is 0.92 grams per milliliter. So water is more dense than oil. When the Alka-Seltzer is dropped in, it creates carbon dioxide bubbles, and the bubbling effect happens here. These carbon dioxide bubbles attach themselves to the pockets of the purple water. They rise to the top of the bottle and then fall slowly down again. The carbon dioxide, when dropped in the water, reacts by rising to the top. So the CO2 rises to the top and then is released from the surface. My Alka-Seltzer had like an unknown purchase date. It was pretty old, so I think that's why my bubbles weren't as strong and bubbly, if that makes sense. So some concepts from class that I did a little bit of research on was that I found the chemical formula that shows the reaction of Alka-Seltzer and water together. And Alka-Seltzer is made of sodium bicarbonate and citric acid. So when they react, and this happens, they create carbon dioxide gas. And so I have that down below, where sodium bicarb plus citric acid, and then we get sodium citrate with carbon dioxide and water. And I added a little photo of my Alka-Seltzer tablets, like how I crushed them. And just a real life application that I thought was really interesting, that I had totally never thought before because I don't have a super strong background in chemistry, was in the grocery store you see bottles of dressing that are like oil based, and oil is always on the top and the rest of the ingredients are on the bottom, because oil is less dense than the more water based ingredients. And I always kind of knew that, but like this totally explains it for me, and I thought that was really cool. Thank you for your time.